Welcome to the tutorial on graphing function transformations. We are going to be using this graphing software, Microsoft Mathematics. You can find it in your Startup menu under All Programs. We're going to be graphing the function f of x equals x squared, and we are also going to be graphing the transformation f of x minus 4. So we're going to take all the x values, decrease them by 4, and then apply the function. To do this, we're only going to be graphing a few coordinates of the function, not the whole function. So we can see what happens to them individually once the transformation is applied. We're going to be in the graphing tab. We're going to be here under data sets, so we can type in specific points. Click here, you'll get a nice, easy to use XY table. I'm going to use the inputs -6 all the way up to +6. Now I've already applied the function myself. I've already squared all those values and graphed them. So -6, square it, you get 36, so on and so forth. Go ahead and press OK. You press graph and it will plot all the points for you. Now we're going to apply the transformation to those same input values, and we're going to see what happened to them. So back to data sets. We're going to open a second data set. Use the same input values, -6 to 6. Now let's go ahead and apply the transformation. I'll just point out two examples. If the input is -6, the transformation says to decrease it by 4, which would get us -10. Then we use that in the function x squared. So we take -10, we square it, and we get 100. We continue to do this, and then you're going to notice that once we get to the input value -2, the output we get is one that we've seen before. That was in the original function. So we take -2, decrease it by 4, you get -6. Square that and you get 36. So this has already appeared in the original function, it just had a different x-coordinate, a different input value. And as you go on down the list, you're going to see they're all repeating again. So when I put -1 in, my output is 25. Well, that used to be the output for -5. We see 16, 9, 4, 1. So they're the same outputs of the original function, they're just reassigned. Now, in order to illustrate why that happened, I'm going to actually save this graph as a picture, which you can do by clicking right here, this button, Save Graph as a Picture. And here it is. And then I'm actually going to open this JPEG file with paint so that I can draw on it and highlight exactly what happened. Let's go ahead and see if zooming in a little will help. Oop, too much. Okay, we'll leave it be. Alright, so let's take a look at our first input value of -6. Normally, the output would be 36. However, in the transformation, the output for -6 is much greater. It's actually 100. Why is that? That output, -100, is really what is supposed to be the output from -10. Normally, -10, when you square it, would get you 100. That output value has been reassigned to a new input value. Again, we see that happens here. At -5, our output should have been 25 with the regular function. When we applied the transformation, it got much higher. It became 81. It was reassigned from the earlier input value of -9. And this is happening to each output as we apply the transformation. It's getting reassigned. And now we're getting here, normally the output of -2 should be at 4, and look what happened. We're getting the output of -6 instead. We're getting 36. So now we can go ahead and see what happened on our graph. This input, -2, we were told to decrease it by 4. So let's do that. 1, 2, 3, 4. This output is then the new output here. So it went backwards 4, and then it took the output and reassigned it to itself. That happened here again. The normal output for -1 should be a +1. Instead, the transformation said, go backwards by 4, decrease your input, and then take that output and reassign it. And that's going to continue to happen. Go backwards by 4, take that output and reassign it. So everything is actually shifting to the right. It's going to get a little convoluted here, so let me switch lines for you. This output is reassigned 4 spaces to the right. This output is reassigned 4 spaces to the right. This one, it's going to be a little hard to see now, it's reassigned 4 spaces to the right, and they continue to move 4 spaces to the right. The 0, you can see, is reassigned there. This one, oops, I skipped one, excuse me. It's hard to see when they get so crowded. This one got reassigned here. Now I'm going to go to purple. So consider, how about, I guess purple you'll see better. Now this one, actually, the one that overlaps, the blue output got reassigned to this green output. Let's see if I can get it. There. So this blue output got reassigned there. And they're going to continue to get reassigned 4 spaces to the right. And we can actually see how the function is going to be transforming. So the original function was at y equals x squared. And when the transformation was applied, every single output got reassigned 4 spaces to the right, and that's going to continue to happen the rest of the function. Okay, your job now is to also use Microsoft Mathematics to plot the coordinates for the function f of x equals x squared, but you're going to apply a different transformation, which is on your worksheet. It would be f of the quantity x plus 3. I also want you to either print out the graph you made, or you can save it as a JPEG and then open it in Paint and show with colors how each point was transformed. And this will be what you turn in. Okay, I hope this was helpful. Thank you for listening.